Hello, welcome everyone. For today's video, we're going to tackle the job assignment problem, the final report on operations research. Today, successful businesses all around the globe heavily utilizes the power and functions of mathematics, specifically statistics, in making decisions in order for them to have the maximum business profit. And one of these is the idea under job assignment problem. Join me as we will explore the concept behind assignment problem with emphasis on Excel application. In this discussion, we will going to have the following learning objectives. Number one, determine what is an assignment problem and solve problems involving assignment problem through the use of Excel application. So what is an assignment problem? The assignment problem is a special type of linear programming problem where assignees are being assigned to perform tasks, say, let there be M workers and N jobs. Any worker can be assigned to perform any job, incurring some costs that may vary depending on the work job assignment, in such a way that the total cost of the assignment is minimized. In short, workers will be assigned to perform jobs, incurring some cost in such a way that the total cost of the assignment is at the minimum. Before we will go into solve job assignment problems, within this discussion, we will have the following assumptions on the problem that we will going to analyze and solve. Assumption number one, the number of assignees and the number of tasks are the same. Each assignee is to be assigned to exactly one task. Third, each task is to be performed by exactly one assignee. Fourth, there is a cost associated with the assignee performing task. Fifth, the objective is to determine how all N assignments should be made to minimize the total cost. So, say for example, number one, 3 jobs, job number 1, job number 2, and job number 3, are to be assigned to 3 persons or workers. Say, the first worker is Alice, the second worker is Troy, the third worker is JR. The processing costs are as given. So if Alice will work the first job, or the J1, it will cost 19 units. And if she will going to work for job number 2, it will cost 28. And for job number 3, if Alice will going to work for that job, it will cost 31. On the other hand, if Troy will work for job number 1, it will cost 11. For job number 2, it will cost Troy to have 17. And if Troy will work for job number 3, it will cost 16. Furthermore, if JR will work for job number 1, it will cost 19. And if JR will work for job number 2, it will cost 15. And if JR will work for job number 3, it will cost for the production 13 units. So the question is, which job allocation will minimize the overall pricing cost? To efficiently solve this problem, we will going to use Excel, specifically the solver add-in. So before we will going to solve problems involving job assignment problem using Excel, we need to activate first our solver add-in by doing the following. First, go directly to the file menu and then click the options, go to add-ins, and you will be directed to Excel add-ins and click go. And then kindly check the solver add-in. Kindly check the solver add-in and then you are ready to go. So let us answer the given problem. So in this situation, before we're going to solve problems related to job assignment, we need to understand first the constraints. So what are constraints? So constraints are the cases or limitations that should be considered or satisfied first prior to the determination of the optimum solution. So in this case, let us define first or determine first what are the constraints. So number one constraint is that each job will only be done once. So in short, the demand for that job, say for example, job number 1 is 1. Okay, it is equal to 1. It's equal to 1 simply because based on the problem, based on the assumptions prior to the presentation of the problem, all the problems found in this presentation follows the assumption that one job is to be performed by one worker and it will be performed only once. Okay, so same goes with job number 2, it is equal to 1. And job number 3, the demand is also equivalent to 1. And then on the other hand, there is also another constraint or series of constraints. This is all about supply. So in this case, what is supply? So in this particular problem, supply is associated to workers because the workers are the one that will going to provide, they are the one that will going to perform or to accomplish the task. It means that supply therefore is directly associated to the number of workers or to workers itself. Hence, we can simply say that Alice can provide, since the work or workers can only do one single job, it means that Alice can only provide one or one supply. Say for example, we're going to use that idea for C. So Alice can only do one job, means that he can only supply one. Same goes with Troy. He can also perform one job, and same goes with JR. He can also perform one single job. So to effectively answer this one using Microsoft Excel, specifically utilizing the solver add-in, it is advisable to craft a similar table based on the original table. We're going to craft a similar table, but in this case, we will going to add additional row, and additional column. So let us start first with the column. In this column, we're going to identify this one as the total assignment. It is understood that the total assignment of Alice supposedly is 1. Okay, but we're not going to directly state that one as 1, but we're going to use the formula equal sum of the cell under Alice in the row intended for Alice across the 3 jobs, which means that since we don't know yet on which job Alice will going to perform, we will going to use this formula. So sum P5 to R5, and that is also true to the cases of Troy and JR. So we're going to directly drag that one. So this one is the sum of P6 to R6, and then this one is the sum of P7 to R7. On the other hand, there's also an additional row, wherein the row that we're going to add for this one is the number or the total number of assigned job. Okay, so it is understood that the job to be performed by the workers are to be done only once. So it is somewhat the same sense that we're going to directly add or put here 1, since job is to be assigned only once. 1, same goes with second job and third job. But since we don't know who among Alice, Troy, and JR will going to perform, say for example, this is Alice will going to perform job number 1, Troy will perform the job number 2, or JR will perform the job number 1. Since we don't know yet, the same argument with the total assignment, we're just gonna use the formula equal sum of the cells from P5 to P7. So just gonna add the cells, okay, under job number 1. So eventually we're going to, since the output of this one will going to give us an idea who among Alice, Troy, and JR will going to perform. So if it will be Troy that will going to perform, the result for this one using solver add-in, it will gonna come up equals 1, and then the rest it will become 0 and 0 automatically. It means that Troy will going to perform the first job. So eventually the total assigned will also follow that it will only be assigned once. So going further, we're going to use the same argument from job number 2 and job number 3. Just gonna drag that one. So P5, Q5 to Q7, and then R5 to R7. So remember that the ultimate goal of this one is to determine the total cost of the production. When the total cost of the production should be the minimum 1, okay, or the solution should arrive to the cost, which is the minimum one. Okay, so using solver add-in, total cost can be solved using this formula. So we're going to use this formula in this particular cell. That is equal, you need to remember this one is the product, sum product of these cells and these original cells, which is intended for the cost with respect to the jobs vis-a-vis workers. Okay, so if we are done having this set up, we are now ready to solve this one using solver add-in. So to solve using solver add-in, kindly go directly to data, check solver, and then set objective. Set objective, we're going to raise this one. Set objective, wherein our objective for this one is to have this cell be at the minimum one, wherein our changing variable cells will going to have this one, because this is our ultimate goal to determine who among Alice, Troy, and JR will going to perform the job. Okay, now let me reset all. Okay. So again, this is set objective, this one, wherein our ultimate goal is to get the minimum cost, wherein our variables that we're going to change are the following. Okay, this one. And set the constraints. So let us remember that what are the constraints. The first constraint will be, okay, this cell, the total assignment should be equal to this one, or you can directly put there one and click add. This one should also be equal to 1, and then this one also, the total assignment under JR is equal to 1, and then the total assigned under job number 1 is equal to 1. You can click 1, or you can directly use this cell. Add this one equals 1, and then this one equals 1, and click OK. So we have done the constraints, and then we're going to check make unconstrained variables non-negative. Okay, since we're talking about job, we're going to use the non-negative one. And then on this function drop down, you need to select simplex LP and then solve. At the end, it will going to give us an idea that the following, using the following setup or arrangement or assignment, if Alice will going to perform the job number 1, Troy will perform job number 2, and JR will perform job number 3, we will have this minimum cost. And in this assignment or this job assignment is the setup that will going to arrive at the minimum cost. So that is how we're going to solve problems involving job assignment using solver add-in. So let us try to consider this another example. So we have 4 jobs, job 1, 2, 3, and 4, needed to be executed by 4 workers. 1 job per worker, wherein the matrix shows the cost of assigning a certain worker to a certain job. The same goal is to minimize the total cost of assignment. So again, the first thing that we need to do is to create a similar table wherein there will be visible constraints for the total assignment and then the total assigned works. Remember that since it follows the same assumption in the demand and supply, the argument for demand and supply are just the same, equals 1. And the ultimate goal of this analysis and problem solving is to get the optimum cost. And the formula is the sum product of this cell and the original cells. So let us solve this one using solver add-in. So in solver add-in, you can easily solve this one by setting the optimum cost, this cell. Just remember that this is our ultimate goal. This is our objective, to get the minimum cost of that one, wherein our changing variable cells are the cells intended for work vis-a-vis jobs. And then we're going to add the constraints. So the constraints are the following. Just using the same argument, just going to add. So this one is equal to 1, and then this one equals 1. This one equals 1, and then this one equals 1, and then this one. So we have 1, 2, 3, 4, 5, 6, 7, and 8. So make unconstrained variables non-negative and use simplex for this particular problem and then click solve. So in this particular problem, if we're have going to assign workers for certain jobs when our ultimate goal is to get the minimum production cost, say for example. So this is the particular arrangement. So worker 1 should perform job number 3, the second worker should perform job number 2, the third worker should perform job number 1, and the fourth worker should perform the job number 4, wherein the total cost for that one will be the minimum, which is 140. So that will be all. Thank you.